Everyone, I am Rakshita studying Electronics and Communication Engineering in Sri Venkateswara College of Engineering, Bangalore. Today we are going to discuss about a topic regular falsi method and Newton-Raphson method. Let's move forward to the next slide. Content regular falsi method and its application. Newton-Raphson method and its application. Regular falsi method. The regular falsi false position method is an iterative technique used to approximate the roots of a nonlinear equation. It involves creating a bracket, an interval containing the root, and then updating the bracket based on the function evaluation at the endpoints of the interval. The formula for the next approximation is derived from the equation of the line connecting the two endpoints of the bracket. Where this line intersects the x-axis is the new approximation for the root. The process is repeated iteratively until a desired level of accuracy is achieved. Here the basic formula for the regular falsi method is given an interval a comma b where the function f of a and f of b have opposite signs indicating the presence of a root between a and b. The next approximation x nu is calculated using the formula x nu equal to a f of b minus b f of a divided by f of b minus f of a. Once x nu is computed, you determine the sign of f of x nu and replace either a or b with x nu depending on the sign. This ensures that the new interval still contains a root. That process is then repeated with the updated interval until a desired level of accuracy is reached. Remember that while the regular falsi method can be effective in finding roots, it might not always converge, and careful consideration of the problem and the interval is important to avoid issues like slow convergence or convergence to the wrong root. Let's move forward to the next slide. Applications of the regular falsi method. The regular falsi method, also known as the false position method, is another numerical technique used for the approximating the roots of the nonlinear equation. This method is particularly used when the Newton-Raphson method might fail due to its sensitivity to initial guesses or when a more stable alternative is needed. The regular falsi method has application in various fields including engineering. The regular falsi method can be used in engineering disciplines to find solutions for equations that arise in mechanical, civil, electrical and other engineering domains. For example, it might be used to solve equations related to stress analysis, heat transfer, and fluid dynamics. The second one is economics. In economic modeling, equation that desired supply and demand relationship, cost functions, and utility functions can be solved using the regular falsi method. This can help economists analyze market behaviors and make predictions. Third one is chemical engineering. Chemical engineers often need to solve equations related to chemical reaction, transport phenomena, and equilibrium calculations. The regular falsi method can be applied to find numerical solutions in the scenarios. The fourth one is environmental modeling. Environmental scientists and the engineers might use the regular falsi method to solve equations describing solution dispersion, groundwater flow, and other environmental processes. Let's move forward to the next slide. Numerical analysis education. The regular falsi method is common topic taught in introductory numerical analysis courses. It's used to introduce students to root finding techniques and help them understand the importance of the initial guesses and convergence behavior. The mathematical modeling. In various fields where mathematical modeling is involved, the regular falsi method can be used to find solutions for equations that don't have analytical solutions. This is common in physics, biology, and other scientific disciplines. Third one is finance. The method can be applied to solve equations related to financial mathematics, such as pricing complex financial derivatives or determining optimal investment strategies. First one is artificial intelligence and machine learning. While the regular falsi method might not be as commonly used in modern machine learning and AI, it still plays a role in certain optimization problems or when dealing with the specific mathematical constraints. Second one is electric circuit analysis. The regular falsi method can be applied to solve non-linear equation that arises in electrical circuit analysis, helping engineers analyze and design electronic circuits. The third one is hydrology. Hydrologists may use the regular falsi method to solve equation describing the flow of water in rivers, lakes and aquifers as well as in the flood forecasting and water resource management. Similar to the Newton-Raphson method, regular falsi method has its limitations and considerations. It may also suffer from slow convergence or convergence to a wrong route if not used appropriately. As with any numerical methods, understanding the problem, its characteristics, and the behavior of the method is crucial for achieving accurate and reliable results. Let's move forward to the next slide. The second topic is Newton-Raphson method. The Newton-Raphson method is another iterative numerical technique used to approximate the roots of a nonlinear equations. It involves using the derivative of a function to update the approximation in each iteration. Getting closer to the actual root, here's the basic formula for the Newton-Raphson method. Given the initial approximation 0 into 0, for the formula for the next approximation nu into nu is calculated using the following equations. Nu equal to old minus old into f dash of old into new, that equal to x old minus f dash of x old into f of x old, where old x old is the current approximation. Old of f of x old is the function value at old into old. Old into f of x old is the derivative of the function old into old. The process is repeated iteratively until a desired level of accuracy is achieved. The method converges rapidly if the initial guess is close to the root and the function is well behaved around the root. It's important to note the while the Newton-Raphson method can be very efficient in converging to root, it can also fail to converge or converge to wrong root if the initial guesses is poor or if the function has certain characteristics that causes convergence issues. Also, computing the derivative accurately can be challenging for some functions, so careful consideration of the problem and the choice of initial guess is essential. X n plus 1 equal to x subscript minus f of xn by f dash of xn. Applications of Newton-Raphson method. The Newton-Raphson method, often simply called the Newton method, is an iterative numerical technique used to find approximate solution to equations. It is particularly effective for finding root solutions of non-linear equations. The method starts with the initial guess and refines the guess in each iteration, converging towards the actual solution. The Newton-Raphson method has various applications across different fields, including first one is root finding. The most common application of the Newton-Raphson method is finding the roots of the equation. This can be used in a wide range of scientific and engineering problems where analytical solutions are difficult or impossible to obtain. The second one is optimization. This method can be applied to find local minima or maxima of a function. It is used in optimization problem across various fields including economics, engineering and machine learning. The third one is physical engineering. Many physical and engineering problems involve complex equations that do not have straightforward analytical solutions. The Newton-Raphson method can be used to solve these equations numerically. For example, it's used to analyze electrical circuit, mechanical systems, and fluid dynamics. Let's move forward to the next slide. The first one is control systems. Control systems involve analyzing and designing systems to maintain desired behaviors. The Newton-Raphson method can be used to solve equations related to control system dynamics and stability analysis. The second one is numerical analysis. The Newton-Raphson method is a foundational concept in numerical analysis. It's often taught in courses that cover iterative methods for solving equation and differential equations. The third one is financial mathematics. In finance, the Newton-Raphson method can be used to solve equation related to pricing option, risk management, and portfolio optimization. The fourth one is computer graphics. Certain computer graphics algorithms such as ray tracing, surface rendering involve solving complex equations to determine lighting, shading, and other interactions. The Newton-Raphson method can be applied to solve these equations numerically. Conclusion. Both the regular falsi false method and the Newton-Raphson method are numerical technique used to approximate the roots of the nonlinear equations. While they serve the same purpose, they have distinct characteristics and advantages that make them suitable for the different scenarios. The regular falsi method is an iterative approach that utilizes the intermediate value of the theorem to narrow down the range in which the root lies. It starts with the two initial points that bracket the root and then iteratively adjusts one of these points based on the function values at those points. This method guarantees convergence to the root, but its convergence can be slow, especially for the function with flat regions or irregular behavior. Thank you for watching my video. Please like, share and subscribe my channel.